Hello everyone. So I can see I think 4 viewers are waiting here showing. So I think so this is the first live session of dynamic behavior of materials. So as you I think hopefully you are following the course. This is kind of a new course. I mean even in IIT Guwahati we uh, we do not have that course as an elective event. Probably in future we will float it as an elective. So I think I'm not sure about other institute of India, but this is we are not in a like we as I told you we generally do not teach this course, but I think I hope that this course will help you. Um, I mean, especially who are working in dynamic behavior or materials field. This course, although we have like I think wave propagation. This is not focus is on not on wave propagation. So that is probably you may have probably taken some other courses like stress wave propagation kind of courses. Here also in I think IIT Guwahati we have a similar course in civil engineering department, stress wave propagation. But our focus is on mostly on materials, not on wave propagation. So how the materials behave during dynamic loading. So that's what our focus is on. And as you know that we are following mostly Mark Meier's book, that is Dynamic Behavior of Materials. So we do not have another book which the entire uh, topics covered in this area. There are some other books, but generally for this course as you can understand, I follow entirely Mark Mears and some little bit of here and there, I mean some other sources, but very little. And I think, but Mark Mears book, one disadvantage is it's an old book, so some of the things I had to check, some updated literature. But still, I think I admit that we can improve this course a bit and and incorporate um, probably more and more updated you know theories into this. So one thing I actually I must apologize for this. Probably for recently I got a lot of doubts, but I could not answer. Especially in the last week, I was very busy, and even the weekend I thought, but due to some emergency work, I could not do it. But yesterday I checked the doubts, so I will probably discuss these doubts. Some of you have asked some of the doubts, and so earlier doubts. I think hopefully whatever I answered is probably your whatever confusion you had hopefully clarified uh, through my answers. So if not, please write it again. Generally, my TA teaching assistant, my PhD students, they give the doubts together. I mean, I generally don't check on the website, so they give me a one consolidated list of doubts and then or questions. So then I reply at as you can understand like after a week or so. But yeah, anyway, so these doubts whatever you have posted, I got these doubts and surely I will post the answers by tonight or so. I mean I already had gone through these doubts. So some of these doubts are like I want to I will just read and like I will just tell here. I mean, what are the probable answers? So I can see only one viewer here now. I don't know. I mean, others are probably already left. But anyway, so first doubt I will just read the doubts and hopefully all of you know that. I mean, all of you have probably read the already doubts in the discussion forum, and so the first one is this is I think from maybe I got the doubts till I mean I don't know maybe a week or more than a week before. So, but after that I have here, so I will just tell you. So first is the question was the shape of elastic stress wave is a rectangular shape, or why not it is like triangular or other shape? And then is the shape of elastic wave always rectangular, and what is the shape of plastic longitudinal shear stress wave, shear stress wave? So this depends on the actually projectile bar shape. So what happens is in these cases, let's say for Steel Hopkinson pressure bar, we generally use a projectile bar which has a uniform cross section along the length. So if your bar is a pure cylinder, that means a uniform cross section, along the entire length, then you should get a rectangular waveform. But then when you use a tapered bar, sometimes people use tapered bar. That means at one side it is the diameter is big and the other side the diameter is small. Then what will happen is that will actually create a waveform which is not rectangular. So that will be kind of triangular shape. So if you imagine a you can search on that on the internet, probably you will get it. But you can I mean that you can write that conical projectile bar or tapered bar. You can search like that. So what happens is when it is uniform, so uh, you can understand that the back face of the projectile will also, I mean, exert that force, and it will uh, keep the stresses constant. But if you have a conical shape, so what will happen is whether you have I mean, suppose your the end of the projectile bar which will be in contact with the incident bar has the same diameter as the incident bar, but the other end is probably, let's say, with a bigger diameter. Then in that case you will get a waveform which is not rectangular. And then also sometimes people use some rubber kind of material, elastomeric material on the end of the incident bar. Then also the waveform may be changed, the shape of the waveform may be changed. And then plastic wave also, I think if you keep the uniform, I mean uniform cross section, then the plastic wave form will also be kind of rectangular. And another question is higher stress wave travels at lower speed and vice versa. That is regarding this plastic wave velocity. So plastic wave velocity is proportional to the square root of the slope of the stress strain curve in the plastic region, that I mean, in the elastic region, for the elastic wave, we say that the elastic wave velocity is square root of your Young's modulus divided by your density. Similarly, in the plastic region, we do not have a Young's modulus. We have that is, but equivalent is we get a slope of the curve d sigma by d epsilon. So that um, you know you need to understand that slope of the curve, that means that describes the strain hardening, the measure of the strain hardening. The slope generally for most of the materials with strain hardening, you will get to know that your slope of the curve decreases with increasing strain. So uh, what happens from this formula, like plastic wave equal to square root of slope of the stress strain curve divided by density. If slope decreases, um, that means the slope will decrease at higher stresses, and then if slope decreases, the wave velocity will be lower. So I hope that is I mean clear from this. So then the another one is, I think, about the integration, velocity variation, that is from, I think, that's, I think, von Karman and Dewey's experiment. That actually integration, the question was why it is yeah, it is written that it is the integrating up to zone 3, but I think the answer should be this integration was performed at x equal to 0 only. Stresses vary from 0 to sigma 1, the maximum stress. That is, I think it is difficult to describe now here, but when you see the questions, when you see the answer, then you will realize it. And then the question is, another one is, I think some of the questions, one or two, I did not understand. Please, I wrote, I'll write, then please you can rephrase the question. I could not understand it. And that is the one question regarding the, specimen hit by shear wave, and due to impact, longitudinal wave will also get generated. And if the amplitude of this wave is greater than the yield strength, plastic wave gets generated. So that I think I could not understand about the torsional wave. I think in the experiment both torque and impact are applied, and hence shear and longitudinal both plastics waves will be generated. So I don't know what the question says, or otherwise you please rephrase the question. And again, the next question also I am a little bit confused about the area A naught. Sometimes you please, because this course I taught more than a year ago, and I'm not in very much touch with these course material. So please, most of the questions as you did it like with the video link, no, that will be better for me. Like you can tell that. Okay, you already did probably for this question also, but probably better if you specify exactly where it is. So that I did not understand, but only one or two questions is like that. Others are very clear to me. So one thing about the confusion is about the density during the plastic deformation. Generally, during plastic deformation, we assume that volume is constant, and that's why density will be constant. Generally, what happens in elastic deformation, volume is not constant. We consider like that, and in plastic deformation, we assume that the volume is constant. So you can check any mechanical behavior of materials book. What happens exactly in realistically, if you see, probably plastic deformation is also involves all those dislocation movement or dislocation generation. Those things we will discuss in our subsequent lectures. So there are a lot of assumptions probably if you need to make to assume that plastic deformation does not involve any volume change. But still, our basic the courses, we assume that in plastic deformation volume is constant. That's why we will assume, because mass is constant, and then we assume the density is also constant. And yeah, about there is another question. What is please stop. What is the I don't know my. What is that? Stop disturbance email. What is that? What is this? Or probably I don't know what Mahesh Jani is writing. So probably he's getting some disturbance, or probably okay. So you will anyway will get this video, right? So what I'm not sure what you want to through email. But anyway, so I think, yeah. So impact velocity. One questions, I think the V1 should be the velocity of impacted weight and rigid plate both. So the impact velocity should have a velocity V2 greater than V1. That is again from von Karman and Dewey's experiment. So yeah, impact velocity V1 means the drop weight obtains that velocity when it impacts the plate after the free fall. So the drop weight will be in a free fall, like it is under gravity only. So it will when it will impact the plate, uh, you know it is actually V1, although it is probably written as the plate and the uh, weight will get a velocity V1. That means probably we can neglect the weight of the plate, and that is the same velocity. I mean, velocity of the drop weight, and after the impact velocity to the drop weight plus plate, that we can assume it as same. So yeah, another doubt on reference configuration, density and area are taken in reference configuration, and is the tensor causes stress or first pure occur of tensor. So it's basically the analysis is done with respect to the materials configuration only. It may be little, yeah, maybe it's a little, confusing, but still this is with respect to the materials configuration, and the stress is also, that's why it is respect to the initial area. And then another thing that was actually my mistake, there is a typo, during the first assignment, I think question number 8, that you were right, that should be 10 to the power 13, not 10 to the power minus 13. Sorry about that. So we will probably, we will try to remove this question from the evaluation. So that will, I think, that will not should not create a problem for you. And so, yeah, regarding other doubts, I think, yeah, there are several other doubts, but um, okay. So there is another doubt in the von Karman's Dewey's experiment. So there are two velocities. The plot is there, velocity with elastic wave velocity and plastic wave velocity. There are two velocities only, elastic and plastic wave velocity, and in between there is a variable x by t. That we cannot actually, probably should not call it a velocity, but that x by t is a variable which is plotted with respect to strain. That's all. That may be a little bit confusing. And about the, I think, Taylor's impact test, and one question is plastic deformation is rectangular in one case and then after that is tapered. Yeah, that's actually, you can assume it in the beginning also, you can assume it as tapered only. Yeah, that I understand, that is confusing because you have first rectangular and then you have I showed different cases, that is directly from Mark Mears book, but this case, second case is rectangular, and then after that you are getting trapezoidal shape of the deformed portion of the bar, that means the projectile bar. That I think should not be the case. Better you think that all are trapezoidal. And also, if you can check real experiment images, so you can even get some photographs, images, and on the internet, and in some papers, research papers, or sometimes you may get some YouTube videos also. They probably are there on Taylor's impact test. So where you will get the simulation or even experiments also. So how the how exactly the deformed shapes are. And also for it is isotropic materials, it can be tapered, but for anisotropic materials, a different kind of anisotropic materials, the shape may be a little different, and because that's not that may not be very symmetrical. And then as you know, if you increase the impact velocity, if the impact velocity is very high, the material at the front end will spread out, and that spreading will be, we call like mushroom shaped region, and then that mushrooming will happen. And then you can see that sometimes what happens, if you see the real experiments or simulations, so what happens is you will get a pure mushroom kind of shape, and after that, adjacent to the mushroom shape, there will be another portion where you will get plastic deformation. So which is, there are two distinct reasons actually. If you see simulations, experiments, and you have a high impact velocity, then you will get a very flat kind of mushroom shape, and then after that you have another adjacent portion which will have also plastic deformation, but it's not that thick. So that I think will be, I think it is probably in the Mark Mayer's book also, one of the figures shows the real experiments, that probably we have that shape in there as well. And then yes, Another confusion is that um, yeah, the how in the von Karman Dway's paper, uh, yeah, how the interaction of waves, why will the stress reduce to zero? Oh, I think that is from the Taylor's impact test. So what happens is when you have the elastic wave which is traveling ahead of the plastic wave, and the elastic wave will go to the back end of the projectile bar. Yeah. So yeah, if you have some queries, you please post it. I mean, there are, I think I can see that 7 viewers. So I am just discussing, and also if you have some queries, even we can even write it in the discussion forum also again when we can add it to you like those things. So anyways, I will post these queries. So whatever queries you have asked, I mean. Till probably till now. So I will surely do it tonight only. My TA will do that. I will give it to him. So the another the query is regarding this. I think this is, but this question is little bit probably messed up. I think somehow I didn't get it. Like you were asking about a Taylor's impact, and then you have von Karman paper also. I think that is from the von Karman. That the other one is I think from the Taylor's impact. But anyways, somewhere else also I saw that same query. So when you have the Taylor's impact test, so what happens in uh, the when the elastic wave start propagating from the impact interface. Sorry, impact interface. So the elastic wave will be followed by the plastic wave. So elastic wave will be go to the back end of the projectile, and then it will come back. And that comeback means that will be a tensile wave because that's a free surface on the back end. So the compressive wave will come back as a tensile wave. So that tensile elastic wave with the compressive plastic wave which is behind it earlier, so they will interact, and then interaction will reduce the stress. And if the interaction continues like repetition, then it will be the stress will be reduced. So that's what. And about the small strain theory, I think we can go ahead with small strain theory because these analyses are very much simplified, both the Taylor's impact test and von Karman's and Dway's impact. It is the test, plastic wave propagation test. They are actually highly simplified. There are a lot of assumptions in there, and yeah, I think. And also for a Taylor impact test, there is one confusion. I think I have mentioned it somewhere, but if I have not mentioned it, I need to check actually. The Taylor's impact test is, as I told, it's very simplified one. There are a lot of assumptions. So one assumption is that the material is taken as rigid, perfectly plastic material. You know what is rigid, perfectly plastic material? So the stress strain curve goes like vertically up on the y-axis, and then horizontally parallel to x-axis. So the stress strain curve. So it is perfectly plastic, means there is no strain hardening, and yeah, it is. That's why some of the confusion regarding this, why the amplitude of elastic will be sigma yd, or why the stress is not increasing and the plastically deformed when the plastic form moves. So these are actually basically because of the assumptions, and even there are other assumptions as well. There is no radial inertia, and all those assumptions are also there. Basically, these are they have made something very simplified, but still it gives good prediction. But we need to understand they are very simplified models, not like, because pure materials will have strain hardening. Here it is only um, rigid, perfectly plastic material. And yeah, so One more question I did not understand, so I will write it. So kindly rephrase it, so then it will be better for me. Um, yeah, as I told, no strain hardening model. And one question is the plastic wave velocity and the elastic plastic interface velocity is same? Yes, they are same in the Taylor impact test. Uh, mm, and yeah, so what is the approximate ratio of elastic and plastic wave velocity? It depends on, I think, material properties. It is, it's difficult to tell now. And then shock wave velocity and sound wave velocity, they are actually equal. They are assumed to be equal at zero pressure. So we will get that. I think what you have studied till now, that does not include that probably. So I mean, if you extrapolate it to zero pressure, then I think shockwave velocity and sound wave velocity are equal. Then after that, at very high pressure, I think sound wave velocity will be even higher than the shockwave velocity. So, yeah. So if you do not have any queries, so I think, yeah. Anyways, I will update, upload these in on the in the discussion forum. Hopefully by tonight. I will try my best tonight, because I will just give it to my TA. Then hopefully he'll be doing that. I have three four TAs, but I one of them only now available. Others are actually, I mean, it's not available. So I think hopefully he will do it today. So, and please, post your questions here, or even in the discussion forum. You are encouraged to do that. But sometimes I take time, and because of a little hectic schedule here nowadays, we have this, because of this pandemic, we are now having classes on Saturday. I have class on Saturday, and then also we have, we need to record the lecture, so that is little more time consuming than the regular classes. So yeah, but anyways, you are most welcome to, post your doubts in the discussion forum. So I may take time, but anyways, I will give you answers. And if you are not, the answers are not clear to you, then you can probably write it again. And some of you, I have seen that one or two questions I got again. I mean, probably the answer was not clear. Then he wrote to me again, so that's good. And hopefully the assignments are, we made it, that way that it has multiple choices, multiple selection answers. So hopefully you have done well in the assignments. And for the exam will also be, I think you will understand that if the exams are generally in MOOCs courses are similar to, the assignments. So yeah, they will be, those questions in the exams will be similar to the assignments. So I think, um, uh, but you need to study little hard to score well in the exam. In the last years, from last year's experience, I can see that many students could not do well in the exam. And it was actually the passing, percentage is very less. So I think hopefully this time more students will pass. So more percentage of students will pass. I hope so. Yeah, if you do not have any more queries, so we can probably also stop this session. Please write it if you are. I can see that there are 4 or 5 viewers. If you have any queries or regarding whatever, not only like only doubts from the our classes, but you can have some other queries as well. And regarding the book, that I cannot help. As I told, some of you have asked, I cannot actually uh, give you some copy. Although our library now is getting a e-book, but that is only for our students, IIT Guwahati students. And also, I think, I don't know, some students get some PDF copy, which may not be legal, but or if you have in your institute, if you have that book, I think most of the institute, um, may not have these kind of books that is very advanced or very specialized one. But I hope that we somehow get this book because we are following exactly from the Mayer's only, Mike Mayer's book. Yeah, that's all. I think, yeah. If you do not have any query, so we can stop the session here. Thank you.